Good morning, all. I welcome you all for next session. In this session, we are going to see the type of rectifier. In this, we know that there is two type of rectifiers are there. One is full wave rectifier and half wave rectifier. I think for the past classes we are discussed about half wave rectifier and full wave rectifier. We have two types. One is center tapped and bridge rectifier. And today's class we are going to discuss bridge rectifier in depth. So before that, what is the device we are using to rectify it? Anyone? Yes, of course, we are using diodes. So for the half wave rectifier, how many diode we are using? Yes, one diode only we are using. For the full wave rectifier, of course, we are using two diodes. So today we are going to discuss bridge rectifier. In that, four diodes we are using. So just keep in your mind, the bridge rectifier we need a four diodes. So based on this, the connection of four diodes is look like a bridge. That's why it's called as a bridge rectifier. So just we have to recall what is simplest device we are using for rectification. That's we are using diodes using a made up of semiconductor, and the efficiency of the full wave rectifier is 81.2, and for half wave rectifier is 40.6%. And today's we are going to discuss that is AC to why do we need DC to AC, and core problem of bridge rectifiers, that is rectifiers, and smart solution and application of real world. So why do we need DC supply? That is devices need DC supply. So because the problem here we are empathized DT based empathize, we are listed few problems. So one is the phone maybe it's heated more, and battery drains fastly, and the output is not smooth because of the ripple factors are available. So based on this, we need a DC. These are the empathize this as a problem. And for the defined part is the core problem. Here I have listed three of them. One is the rectifier, that is half a rectifier we're using. It wasted half of the rectifier, half of the cycle. That is here. See the diagram. Here there is the half wave rectifier means here wasting negative half cycles, that is 50% of cycles we are wasted, and high ripple pure efficiency and more number of hits. That's why we are mentioned in the empathy part, and it's not suitable for the power electronics devices. Based on this, the problem, based on this we are giving the solution. So we go for the rectifier to find the or ideate the solution for the particular problems. That is here already I told you, that is four diodes are we are using to convert AC supply into DC supply. So from input we are giving AC supply. It shows in the diagram, that is the yellow circle. We are draw the AC symbol. So we are giving input of AC, and here we are loading the connected with the resistance. We know that resistance output is DC only. So based on this, we are connecting D1, D2, D3, D4, four diodes, and just you have to keep in your mind how to connect. So while we are writing the examination, we have a few confusions are there. So how to connect the positive and that is anode and cathode. So just like that we can't connect. So just keep in your mind, we are having two terminals, that is a positive terminal and negative terminal for the output device. So always the positive terminals are connected in two cathode of the diodes, and the negative terminals always connected to anode of the diode. So it's like opposite direction, just you have to keep in mind, but it is not a opposite direction. That's it is the shows the current direction. That's why we are connecting always the positive in the negative, and negative in the anode side. So just keep in mind while you are writing the examination, and draw the diagram. So for the positive half cycles are for the working time, that is in positive half cycle we are giving the input. So D1 and D2 are conduct, and D3 and D4 are in the negative half cycle, that is non-conduct. So in positive half cycle D1 and D2 will be conduct. So it will be give the output. So current will be flow through this D1 and through the load and D2, and it is connected, the close will be, so current direction will be D1 through the load only, through the D1 positive signal, here we are put the positive signal, no, so through which we are leading the current. So for the negative half cycle, D3 and D4 will be conduct, and D1 and D2 are not conduct, because of it is both are in the reverse direction, and D3 and D4 in the forward conduction. So again we are giving the connection, so like this through the D3, and it will be give the connections. So current direction will be always positive to negative, so that's why we are giving the connection. For the cathode we are giving the positive cycle, and anode we are giving the negative cycle. So this is the output of your full wave rectifier. So we are giving the AC input. First you have to draw the AC input waveforms, and for the D1 we are conducting the positive half cycle, it gives the output, and for the D2 current, the negative cycle of the output will be shown. So finally total output will be the positive and negative are together, we form a full wave rectifier. Likewise we have to draw, and just you have to keep in your mind, first we have to, for positive half cycle is given the output, negative half cycle is not given, so it will leave the don't draw any symbol here. So likewise for the D2 current, negative half cycle only you have to draw. So finally you have to draw both positive and the negative half cycle, give the output, and it shows the full wave rectifier. That is the full wave rectifier works in both half, positive half cycle and negative half cycle will be working, and it will be give the output for the devices. So rectification factor, rectification efficiency of the full wave rectifier is 81.2, and the ripple factor is 0.48, and the output of the frequency, ripple frequency, twice the input frequency. That is for 100 kilohertz we are giving the 50 hertz supply. And practical applications are mobile laptops, LED drives, inverters, UPS, and audio amplifiers. All those things I have listed here. The mobile chargers, UPS, and DC to AC inverters. These are the practical application we are using for rectifiers, and the summary of this topic is, first we have to recall the content, and why we need a DC supply, and how to find the define the problem, and how to get the solutions, and the working principle, and real world applications. All those things we have discussed in the lecture. So let's see in the next session. And here I have given the link, reference links for the book materials, and we'll see in the next lecture. Thank you all.